Module 2, problem number 13. Please forgive, I'm losing my voice again, so if you can't hear me, I apologize. Please email me with any questions or let me know if you didn't catch certain parts. Module 2, problem number 13, the amount of time adults spend watching television is closely monitored by firms because this helps to determine advertising pricing for commercials. Complete parts A through D below. Part A, do you think the variable weekly time spent watching television would be normally distributed? If not, what shape would you expect the variable to have? This is kind of similar to what we saw with the discussion this week in the rainfall. Remember how we saw that it was skewed right? That meant that a bulk of the data was on the left-hand side. This is a similar thing. Most people who watch television are going to watch around a bulk of around the mean. Now, a lot more people I would expect watch less TV, but I think there's only so many free hours in a day. So we would not expect a lot of people to watch excessive amounts of TV. So in this case, we would expect this data to be skewed right. Remember, that means that the tail is on the right and the bulk of the data is on the left, on the lower end of the range. So that's option B. The variable weekly time spent watching television is likely skewed right, not normally distributed. Good job. All right, according to a certain survey, adults spend 2.45 hours per day watching television on a weekday basis. On a weekday. Assume that the standard deviation for time spent watching television on a weekday is 1.93. If a random sample of 50 adults is obtained, describe the sampling distribution of X bar, the mean amount of time spent watching television on a weekday. Well, first, what we learned about the central limit theorem is that when you have, when you take that mean, if you're looking at the sampling distribution of a mean, then that X bar is approximately normal. That's something we learned. Oh, it's not letting me select it. Okay, there we go. So, so X bar is approximately normal. We learned that this week in the module. And then mean of X bar, the sample mean, is the same as the mean of the population. If you think about it, that kind of makes sense. If you're taking a sample from a big population and you're just calculating the mean on that sample, you would expect it to be the same or very, very similar to your population mean. So we're going to go ahead and put in our mean, which is 2.45. And then our sigma X bar, let's go over here. Remember, sigma X bar, so the standard deviation of the sample, is equal to the standard deviation, or sigma, of the population divided by the square root of n. That's the sample size. So in this case, our population standard deviation is 1.93, and so here's our 1.93, that's sigma. And then the sample size is 50 adults. So that square root of n is square root of 50. Once you put in that calculator, you're going to get that 0.272943. So let's go ahead and plug that in. 943. Check answer. Nice work. All right. Determine the probability that a random sample of 50 adults results in a mean time watching television on a weekday of between 2 and 3 hours. There are two ways to do this. You can manually convert those two x's, 2 and 3, to your z numbers. That's when you have your x minus mu divided by your sigma. And remember, in this case, we would be doing this for X bar. So it would be for your sample, not your population. Or you can do it in StatCrunch. So, and you've seen both in the videos. The StatCrunch has been in the webinars, and I've shown you manually how to do it in an announcement and in a couple of videos. So this time we're going to go through it in StatCrunch. So let's go to question help, StatCrunch. I'm going to pop that window out. Oops. Here we go. All right, so to find that probability in StatCrunch, we're going to go to Stat, Calculator, Normal. That it tells us the calculator for the normal distribution. See here, you've got your nice little graph. And this is a great way to look around at it. So in this case, we need to input our mean and our standard deviation. So we found that right here for our sample. So we're going to put, let's make this a little smaller so we can see both at the same time. We're going to put our mean is 2.45 and our sample standard deviation is 0.272943. And in this case, we're actually looking for the probability in between two numbers. So we're going to click on between, and we're going to put in our 2, and our 3 here, and we're going to click compute. Much simpler. Again, I know not everyone's comfortable with StatCrunch or using technology, and you really do need to learn how to use the table just to understand what we're looking at here. But once you have done that a couple times, you can use StatCrunch to do this. So 4 decimal places, it says the probability is, we do 0.9284. Check answer. Fantastic. Part D, one consequence of the popularity of the internet is that it is thought to reduce television watching. Suppose that a random sample of 45 individuals who consider themselves to be avid internet users result in a mean time of 0.206 hours watching television on a weekday. Determine the likelihood of obtaining a sample mean of 2.06 hours or less from a population whose mean is presumed to be 2.45. So now we're assuming we have the same population. So we have a mean mu of 2.45. We have a standard deviation. We're going to go back up here. Where was our standard? Is 1.935. So sigma is 1.93. Excuse me, 1.93. And then we need to find our new sample mean and standard deviation, just like we did in part B up above. Let's go over to our calculations here. So part B, again, just like we did up above, we're looking at part D here, look, just like we did for part B up above, we have the sample mean is equal to the population mean, which is 2.45. Now that we have a different sample size, that means our sample standard deviation changes. Because remember, that sample size, that n, is in the denominator. So here we have sigma x bar, or the sample standard deviation, is equal to sigma divided by square root n. So once we put that in the calculator, we get a slightly different number. It's 0.28707. Well, that matters once we go over to StatCrunch to find our the probability. So let's go back. Determine the likelihood of obtaining a sample mean of 0.206. So now we're trying to find, right here we had between, now we're doing standard. We're trying to find what's the probability of getting a sample mean of less than 2.06. We're going to change our standard deviation to what we just found over here, 0.287707. Again, our sample mean didn't change. So we have our mean, our standard deviation, if I could put the decimal point in there, and then we're looking for x less than or equal to 2.06. Let's compute. Oops, I put in 2 decimal places. Okay, compute. And now we're looking for 4 decimal places. So that gives us 0.0876. So let's type that in. Oops. So 0.0876. Check answer. Well done. All right. Interpret this probability. Select the correct choice below and fill in the answer box with your choice. As you can see here, all of them have almost the exact same thing. If 1,000 different random samples of size n equals 45 individuals from a population whose mean is assumed to be 2.45 hours is obtained, we would expect, and this is where they change a little bit, a sample mean of exactly 2.06, a sample mean of 2.06 or less, and a mean of 2.06 or more. Well, we know that we're looking for the sample mean of 2.06 or less. So that already tells us that B is the answer. Then we need to plug this in. We are looking so we have the probability. we know that we're now looking at 1,000 different random samples of this were to be pulled. What would we expect? That means we multiply that answer, that probability we got, by 1,000. So if we were to multiply this by 1,000, we would get 87.6. Right? You go 1, 2, 3 decimal places over, 87.6. Now, it says to round to the nearest integer. That rounds up to 88. Check answer. Nice work. All right, based on the result obtained, do you think avid internet users watch less television? So let's go back up to what this probability meant. This is the probability that the sample mean is 2.06 or less. That's other words of saying the probability that the internet users watch less television. That's a very small probability. That's less than 9 in 100. So we're going to say no, we don't think that that's the case. So no. Final check. Well done. Again, I'm sorry for my voice, and I'm sorry if this is hard to hear, so please let me know if you have any questions about this or anything else.